Okay, in this video we're going to be doing area and perimeter of kites, trapezoids, and triangles. So kind of our last sets of our quadrilaterals here. So a kite, my congruencies in it, remember my top two are the same, my bottom two are the same. Okay, if we do our diagonals, they make 4 right angles, and then these two sets are also the same in them. My top one this one here might be smaller than my bottom one. That's generally what happens in kites. But these left or right ones will always be the same, or my vertex ones. Okay, so our area equation is the same as it is for a rhombus. So 1/2 times diagonal 1 times diagonal 2. Again, it's the entire diagonal. Okay, so if I do diagonal 1 in this, I do 7 plus 7, and I get my 14. My diagonal 2, I do 14 plus 4, and I get my 18. So my A is equal to 1/2 times 14 times 18. And I get 126 millimeters squared. Okay, just like rhombuses, you might have to use Pythagorean theorem to find your outside piece again, because I make 4 right angles. The problem with this is I have 2 the same on the top and I have 2 the same on the bottom. So I actually have to work 2 triangles. So if I pull my little one out, I've got 4 and 7. If I pull my big one out, I've got 14 and 7. I have to use Pythagorean theorem twice because my bottom 2 sets will match and my top 2 sets will match. So I'm going to solve for C in both of them and then round it to the nearest decimal place. So I got these as my C's. So I've got 2 8.1s, those are my tops, and my 2 bottoms of 15.7. So 8.1 plus 8.1 plus 15.7 plus 15.7. I got 47.6 millimeters. Okay, my next one here, that one's 8, that means he's 8, so diagonal 1, I got 8 plus 8 to get 16, diagonal 2, 14 plus 8 gets me 22, so my A is equal to 1/2 times 16 times 22, so I got 176 inches squared. My next one here, diagonal 1, I could do 3 plus 3 and get 6. Diagonal 2, 9 plus 4 to get 13. So A is equal to 1/2 times 6 times 13. So my A is equal to 39 meters squared. Okay, my next one, I'm finding perimeter. Go ahead and add that 12 in there. It should have been in there because you can't tell what it is if I did not give it to you. So my little triangle, I've got 12 and 12. My bigger triangle, I've got 18 and 12. So I'm going to find C, and that will represent my top top and my bottom bottom. So I get that as my C value when I use my Pythagorean theorem. So I've got my 2 top pieces for my perimeter and my 2 bottom pieces for my perimeter. So 17 plus 17 plus 21.7 plus 21.7. I've got 77.4 inches. Okay, my isosceles trapezoid, really we're worrying about trapezoids in this situation. Ooh. So here is my trapezoid. I've got one base here, I've got my other base here. This is going to be my height. So that dashed line, so you are looking for the right angle again to find one base, your height, and it will attach to your other base as well. So if I look at this, first off, my area equation is 1/2 times your height times your 2 bases added together. Okay, so if I look at my right angle here, it connects to my 12 and my 21. So my height that connects my top and bottom is 12. Then I do my top and bottom. So my base one I could say is 21. My other base I could say is 15. It doesn't matter the order because you're going to be adding them. Okay, so then we go ahead and fill it in. So A equals 1/2 times my height times my 2 bases added together. Type it in your calculator. Instead of 1/2, you could type in 0.5 if you wanted to. And I'm getting 216 meters squared. Okay, my perimeter here, it looks like we're missing an outside piece, so this whole thing was supposed to be 25. So if this part of it is 20, that means I've got 5 left. I need to find him to do my perimeter, which also ends up matching that in my right triangle. So if I rework that right triangle out here, I've got 5 and 13, so I could say my A is missing. So in your calculator, you're going to be typing in the square root of 13 squared minus 5 squared this time to get your A, which will then match that outside piece, so I can add them. Getting him to be 12. Okay, when doing my perimeter, what makes it easier is if you cross them off as you go. So my first one here, I got 20. Then I've got 13. That entire base is 25. And then the one I had to find is 12. So my total then, I've got 70 centimeters. So cross them off as you go so you don't leave a piece out. It'll be easier that way. Okay, my next trapezoid, if I find my right angle, that gives me my base and my height, and if I continue it, that touches my other base. So I've got my height that connects my two bases is 5.5. One of the bases is 6. My other base is 14. So 1/2 times 5.5 times 6 plus 14. And I'm getting 55 inches squared. Okay, my next one, that 10 is supposed to represent the whole thing. I know it's a little weird on the picture. Okay, so my area, I've got 1/2. My height that connects my top and bottom is 4. My top and my bottom. So my area then, I'd be getting 32, and we're going to label it units squared. Perimeter, we add up the outside, so I've got 6 plus 5 plus 10 plus 6. So I'm getting 27 units for my perimeter. Okay, my triangles here. An example of a triangle where my height isn't going to fall outside of it is going to look like this. You look for that right angle for your height again. Okay, so finding your right angle will give you your base and your height. So this area equation is 1/2 times base times height. So look for that right angle again. That always tells you your base and your height. Okay, so if I look, that I don't even care about the 13. My base is 12. My height is 5. So then my answer would be 30 inches squared. Okay, that's why I say look for the right angle, because some people get that 13 confused as one of the height or the base. So always find your right angle. That will always tell you your base and your height for it. Okay, this one here, it looks like I need to do Pythagorean theorem to find its outside piece. So I have C, so I'm really going to be doing the square root of 17 squared minus 8 squared to get that last piece. Okay, so I'm getting 15. So then I just add them, because perimeter we add up the side, so 15 plus 17 plus 8. I am getting 40 units. Okay, so finding the area, find your right angle. It is 1/2 times those two numbers that make it up. So when I multiply them, half of 14 is 7, times 5 gets me 35 units squared. Okay, my last one, we're going to find the area, and I'm going to add on perimeter to make it a little tougher. Okay, so I find my right angle. A equals 1/2 times that 10 times the real length of my base. Okay, so I got A equals half of 14 is 7 times 10 is 70. Okay, perimeter is the perimeter of my actual figure. Okay, so I'm going to change this problem a little bit to make it so we can do this. So let's say this also had a 3 meters in here. Okay, first I could use Pythagorean theorem to find this one. So that's what I'm going to do first. So if I do 10 and 3 here, I would do the square root of 10 squared plus 3 squared to get the actual known length of this spot. So I'd be getting 10.4. And then there's actually a big triangle that I can do it again. So my C is missing again, so my big triangle here, that whole bottom is 17, there's my right angle again, and 10, and I'll be able to find my last real missing piece that I need. So I'm still missing C, so I'm going to do the square root of 10 squared plus 17 squared. And I'm getting 19.7. So then I add all of my real sides, so 10.4 plus 14 plus 19.7. So you can kind of work different right angles in this one when it's shifted over like this to find pieces you want. Okay, so my total for perimeter for this would be 44.1 meters.